$1 book. Order that.
All right, so we're going to move on to the next situation here. And the best way probably to do this is to go ahead and start by putting the data up on the board here. So we're going to talk about sports preference. Somebody says, what sport do you prefer? And what we're going to compare is football, basketball, and other. And we're also going to compare this between business program and nursing program. And what we're going to ask them, which do you prefer? And we're going to record, again, the frequencies. So we're going to make this 120, 40, 40. And we're going to make this 240, 110, and 50. What do you observe? Okay, football is most popular. Do you observe anything else?
There's more nurses.
We had more nurses in our survey than we had business people. Anything else? I'm sorry, what'd you say?
The lowest numbers in the other category.
Okay, so other is the lowest, football is the highest, basketball is in the middle. We also have more nursing people than we have business people. But the question that we want to ask is there a difference in the proportions because of the categories? Our null hypothesis is going to be that the categories do not affect the proportions. The alternative is going to be that the categories do affect the proportions. And we'll talk more about what that means in a couple minutes. But this is what we're actually looking for. Does it make a difference between the business program and the nursing program in terms of their sports preference? And you could say it either of two ways. You could say, if you are in nursing, does that change your sports preference? Or you could say, if you have a different sports preference, are you more likely to be in nursing or in business? We don't know necessarily which direction the influence is, right? We don't know if you like basketball, that makes you a nurse, or if you like nursing, then it makes you a basketball fan. We don't know. But we are wondering if there's a relationship between these things. Or is it football? Or is it other? We don't know. But we're asking the question. Now, when we ask the question about proportions, what that requires us to do is to figure out what are the total amounts for each of these categories. So we need the column totals and we need the row totals. Okay? So if I add together the numbers in the first column, what do I get? $200. What about the numbers in the second column? 400.
40 or half?
This is 40. Do we have more nursing students than business? Yes. How much more? It's twice as much. If I look at the football fans, are there twice as many nursing students as there are business students? Yes. 240 is twice as much as 120. This is also twice as much. So in this situation, being a football fan has the same proportion as the overall group. So that means being a football fan does not change the proportions. This is 1 to 2. This is also 1 to 2, if you want to do it like that. Or if you say the business is 1/3 of the total. Here the business is 1/3 of the total. However you want to say it, the football and the totals have the same proportion. We have a word for that, and that is independent. I'm going to close this door. So what we are saying currently is that football fans' proportion is independent of the program that you choose. Because it doesn't matter whether you choose business or nursing, the proportion of football fans would be the same. What about basketball? Is that also 2 to 1 or twice as much for the nursing people? No. So there's something going on there. The same is true for the other category. In the other category, the nursing is not twice as much as the business. So there's something going on there as well. These would be then dependent. So when I look at those proportions, I say, okay, basketball, it looks like there's something going on here. Specifically, it looks like nursing students like basketball more than you would expect, because we expect this number for the nursing basketball people. We expect that to just be twice as big as the business, but it's not. It's bigger than what I would have expected it to be. Same thing with this one, it's smaller. So then, the question is this just a random fluctuation, or is this a population difference? Is this something that's generally true about nursing students versus business students, or is it just for the sample? That's what we have to figure out. But let's find out the totals for these 3 categories. How many total football people do I have? 360. And then basketball is 150, and this is 90. So then, if I look at these numbers, and I say, well, of course, I expect more football fans than any other kind. But here, I would expect the football fans to be 4 times the amount of other. This is 360, this is 90. But that's not what happens. Football is not 4 times as much as other. So when I look at this and I say, well, you know, if I'm comparing the football fans to the other fans, the proportions are not the same as it would be for the entire group. So once again, there's something changing this. There's something different about this. So then the question is, how do we figure this out? Well, we're going to use what is called the test of independence. Now, when we say it's a test of independence, unfortunately, that's a bad phrasing of the word. Because we can't actually test independence. Independence is the null hypothesis. So all we can actually prove is the alternative hypothesis. So technically, it is a test of dependence, not a test of independence. Oh well. So we look at this and we say, all right, what's going to happen? How am I going to figure this out? And what I'm going to need is my critical value. And my degrees of freedom is R minus 1 times C minus 1. R is the number of rows, and C is the number of columns. And notice it does not include the totals that I put on the outside. I only look at the data that I actually observed. I'm not looking at the total numbers, just at the numbers I saw. So this would be 3 minus 1 times 2 minus 1. Which is 2 times 1, which is 2. So this particular thing has 2 degrees of freedom. Well, what's my critical value for 2 degrees of freedom? $5.991. It was before, so same thing. So this is where it gets a little dicey. How do I find my expected values? The formula for my expected values is the row total multiplied by the column total divided by the table total, which in this case is 600. And this is where, I mean, it's not hard in the sense of mathematically, but it's just time consuming. Because I have to come up with all those numbers. I have to come up with the entire data table replaced by another one. So these are all of my observed values here. I need another table with expected values. And how do I get my expected value for that first one? 360 times 200 divided by 600. And this is 360 times 400. This is 360 times 200. Oops, sorry. It's 150 times 200 divided by 600. and so on. 150 times 400. 90, 600, and this is 90 times 400 divided by 600. So for each one of these different cells, I take the row total that it's in times the column total that it's in and divide by the table total. Now, if your mathematical mind is working feverishly, you might be able to reduce some of these fractions without having to multiply everything out, which makes it easier. So what are my expected values then? This is 120, this is 240, this is 50, this is 30, this is 60. Now, I constructed this so that the numbers came out nice, okay? They don't come out nice all the time, but this, I made it so it would come out nice. So then, these don't match what I observed exactly. The football ones match, which is what we said. The football category is not affected by the program that you're in, but these other numbers are different. So these numbers that I have here, these expected numbers, would be what happens when the categories do not affect the proportions. So these numbers in my expected table, notice that all of them have double between the business and the nursing. Because I have twice as many nursing students, all of those numbers show that it's doubled. But that's not what happened. That's not what I observed. So then the question is, are these things different? Are they actually different in a significant way in terms of observed compared to expected? So how do I figure that out? Chi-squared. Observed minus expected squared divided by expected. So now I have another table, and in that other table, I have my chi-squared numbers. These are just 0 because I subtract these come out to be 0. But here I would take 40 minus 50 squared divided by 50. And then this would be 110 minus 100 squared divided by 100. Then this would be 40 minus 30 squared divided by 30. And this is 50 minus 60 squared divided by 60. So somebody got some nice numbers for me here?
Is it 2 and 36 for second column?
It's a 2 in this right here.
1?
This is 1. What about the next set?
Looks like looks like 3.33.
3.33 and 1.60. So those are my chi-squared numbers. And again, what they're reflecting is that my observed and expected don't match up exactly. So now I add together all 6 of those numbers. So my test value, chi-squared, equals 8. So then what do I say?
You reject H or the null hypothesis because 8 is in the rejection region.
I do. So I'm going to reject the null hypothesis. I reject the null hypothesis. What does that tell me?
If there's evidence that the alternative hypothesis is, there is evidence for the alternative hypothesis.
That's correct. So I reject the null, so I prove the alternative. That's correct. What does that mean? The categories do affect the proportions. And that's all I know. The only thing I know at this point is that something is different between the business majors and the nursing majors in terms of their sport preference. That's all I know. Now, if I really wanted to prove that there was a difference, I would have to do confidence intervals for the horizontal and for the vertical. So I would need 24 different confidence intervals here. Well, 12 actually. No? Yeah. 6 for each direction. And then I have to compare them all and see if there's any differences. So I'm not going to do that. That would take too much work. And if I'm going to compare 12 different confidence intervals, which would mean I have to compare 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to compare 10 different confidence intervals. Here's my chance of being right. Would be 0.95 to the 10th power. Because I'm doing something with 95% confidence, and I'm doing it 10 different times, all the different confidence intervals that I'm comparing. What's 0.95 to the 10th power?
.598.
Okay, about 60%. So I don't even know if I'm right when I do this. Okay, if I go out there and I compare all these confidence intervals, I don't know that this is actually working at all. It's just crazy. So if you get in this situation, then you're going to have to get a little bit more advanced in your statistics to try and figure stuff out, because there's so many different possibilities here, and you're trying to compare them all. You're trying to figure everything out. There are ways to make it happen, not necessarily easy ones, but they can work. So that if we look at this and we say it's pretty clear that the nursing people are a little bit higher than I expected, because this is 100 and this is 110. So they're higher in basketball, the business people are lower. Here, the nursing is lower in the other, and the business is higher in the other. So just based on looking at my observed and my expecteds, it looks to me like nursing people like basketball better than business people. Just compared on the numbers. So it seems reasonable to say that that's the case. But if I wanted to prove it, it would take a lot more work. So then, this thing that I've just done, this test of independence, this would be the kind of thing where we would say, does the medicine actually work? Or which dosage of the medicine is the best? Because we'd look at the percentage of people who got better and see if it was different for different levels of the dosage. If I give people 10 milligrams versus 20 milligrams, does it help them better if I give them more of the medication, or is there a problem? How do I know? Well, I have to just give people medicine, right? How do I know if something works? I got to try it. Well, hopefully I've tried it in lab rats or something to make sure it doesn't kill anybody. But it's really, 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 really hard to create a medication and to know that it works and to know how much you're supposed to give people, how many times a day, and all that other stuff, because you have to consider all these different possibilities. And it just gets crazy. But anyway, this is the kind of thing that we're looking at. Is there a relationship between making a certain change and how it changes the proportion of what people like sport-wise? Yes?
Why did you put it to 10 far?
Well, because I have to compare this proportion to that one, so that's 2 comparisons. And then I have to compare this one to that one, that's 2 more. So that's 2, 4, 6, and I have to do it this way. There's 1, 2 that way, 2 more that way, so there's 10. I mean, it's kind of a ballpark thing. But what I'm trying to show you is that this particular situation, even though we're able to use chi-squared and we're able to say that something is different, it's very difficult to find in the details what thing is actually different. You can kind of see it, and it kind of makes sense, but to prove it takes more than we're able to accomplish. All right, so let's try one more of these just on your own and see if we can make this work. So I'm going to compare health insurance. And I'm going to compare people in different states. Okay. But what I'm going to do is I'm not going to take us through all the process. I'm just going to show you what it looks like. Right? So, can I make this different? Bring it over here a little bit. Maybe you can see that a little better. Go over here, minimize that. Okay. So I'm looking at people in these 4 states. Arkansas, Montana, North Dakota, and Wyoming. And I'm comparing how many people have health insurance and how many people don't, with and without. Okay. Now I have the numbers here, and hopefully you can see that I add together, I get my column totals and my row totals. Notice that it's just about evenly balanced between the two. So then I would expect that the with and the withouts would be evenly balanced for every state, but they are not. So then the question is there a significant difference in the proportions of with and without based on which state you live in? So, what are my degrees of freedom here? Three. I have 4 rows, so that's 4 minus 1, 2 columns, so degrees of freedom is 3. What is my critical value? $7.815. How do I find my test value? Well, the first thing I would need to do would be to come up with my expected values. So let's just find one of these. How am I supposed to get this number? 108.04. Minan, can you tell me how I'm supposed to get that number, 108.04? Nope, that's not correct. That would be for goodness fit. That's not what we do. Jordan, can you tell me how to get 108.04?
So it'd be like. Pass.
Okay. Kayla, what do you say?
Yeah, pass.
Okay. JP?
So it would be the 216
216
times the 1472
times 1472.
divided by the 2,943.
Yes. So that would be my expected value for that bottom row first column. Do the row total at the bottom, first column total divided by the table total. And that would be my 108.04. So how would I get this number here, this 0.23? Hillary, can you tell me how to get that number? Okay. Christopher, can you tell me how to get that number? Let me know what 0.23.
Pass.
Okay. Tina?
Would it be 103 minus 108.04 to the second divided by 108.04.
It's actually 108.4. Oh, no, you're right.
Sorry.
No, you're wrong, I'm right. I mean, I'm wrong, you're right. Let's see if we can get that. 108.04 is correct. Yes, you're right. I was. So when we put these numbers in here, we actually make them happen, we would get 0.23. And we follow the same pattern for all those numbers. Now, just looking at what we have right here, what do you think that 12.77 represents?
Test value?
The test value, which would be the total of all the chi-squared numbers. So the test value is 12.77. Chi-squared test value is 12.77. So, Lena Schmidt, what do we say?
You reject the null hypothesis.
What does that mean?
How did I get that, or what does it mean?
What does it mean?
There's evidence to prove each one.
Okay, so we reject the null hypothesis. We say there's evidence to prove H1. Jessica, what does that mean?
That categories do affect the proportion.
Okay, the categories do affect the proportions. So what that means is that if you live in a different state, you're going to have a different percent of being with or without health insurance. So the state you live in changes the percentages. Now, it could also be true that if the percentages are different, then that means people go to that state. You wouldn't necessarily think about this, but you might say, hey, you know what? If I'm concerned about healthcare, I'm going to go to a state that has good healthcare. If I'm not concerned about good healthcare, then I'm going to a state where it doesn't matter. So just the fact that you have numbers that are different doesn't mean you know what thing makes the other thing happen. When you move to a state, does that change your healthcare? Well, sure, that makes sense. But if you want different kinds of healthcare when you move to a different state, well, you could, certainly. People say, oh, I don't want to live there because the healthcare is this way. Or I want to live it that way, so I like to live in a place like that. That could happen. So we don't necessarily know that these things are a certain way just because the numbers are different. We don't know. So this will be like what I'll be asking you on the test. Okay, I'll have all the numbers, they'll all be figured out, but then you show me what they mean, you show me where they come from, you tell me the conclusion, and that's it. We don't have to worry about confidence intervals for this because it'd be just too complicated. Certainly if we thought about it a little bit, and we said, where are the differences? We would say, well, it looks like these have kind of high chi-square numbers. So it looks like North Dakota, it might have a definite higher amount of people with, because that number is higher than this record, and this is lower. So North Dakota looks has higher people with insurance. Maybe. All right, that's good enough for us. And so this homework is due next time. And then we only have one more to do, and then we're all done with homework. Hard to believe.